Welcome to the Quick Train Modeler video training series. This module covers line of sight analysis. Line of sight analysis capabilities are only available in the USA version of Quick Train Modeler. Most line of sight functions within Qt Modeler require a surface model, so I'll begin this demonstration by importing two adjacent LAS tiles into a seamless surface model. Clicking the Import Model Data button launches the Import Model dialog. You can see my input format is set to LAS, and my model format is set to the QTT gridded surface. I'll select my two adjacent LAS tiles by holding down the Shift key and click Open. This launches the LAS Import dialog. Since I have adjacent LAS tiles, I'm going to want to make sure that I process them as a group. This will ensure that I don't have any gaps in between the tiles which could adversely affect my line of sight analysis. Clicking on the Go button will start the import process. Once the import process is complete, my surface model is displayed. It's important to point out that a surface model is not a true representation of reality. Features such as utility lines and trees become solid structures within the surface model, restricting line of sight artificially. It should be also noted that temporal changes from when the data were collected to the current conditions on the ground can also affect your line of sight analysis. Line of sight analysis within Qt Modeler requires markers. If you have markers in an existing format, you can import those under the Markers menu, go to Import Markers. Qt Modeler accepts ASCII files, KML, and shape files. To create new markers, you can click on the Place Marker Pin button and click at the desired location. You can also hold down the M key and click to create a marker. Once you've finished placing markers, you're ready to conduct the line of sight analysis. Click on the Add Line of Sight Map button. This launches the Create Line of Sight Map window. The first step is to select the analysis type. We'll start with the basic coloration. Next, you should select the markers or observers you wish to participate in the line of sight analysis. We'll select all in this case. You can then adjust your viewing parameters, such as the observer height and the target height. Let's stick with the defaults for now. We'll click Apply to run the analysis. A legend is displayed in the lower left-hand corner. You can see that in this case green areas are areas that all the markers or observers can see, yellow are locations which some can see, and gray represent the locations which none of the markers or observers can see from their current position. We can turn on and off the coloration of the line of sight map by clicking on the Toggle Vertex Colors button. Let's go back into the line of sight map settings to make some adjustments. This time we'll limit the line of sight distance to 100 meters. We'll once again choose that all of our markers participate in the analysis, and then click Apply to run the line of sight. As you can see, this imposed a threshold of 100 meters around each marker. Now let's examine some of the other analysis types. The second option, Interactivity, will provide a unique color for each observer. Interactivity line of sight generally works well with 1 to 3 observers. Let's select just our first marker, turn off the limit line of sight distance, and click Apply to rerun the analysis. You'll notice that marker 0 here, which is colored red, all areas which that marker can see are also colored red. Back into our line of sight settings, we'll now select the first two markers by holding down the Shift key. We'll once again click Apply. Marker 0 is red, and all areas which that marker can see are displayed as red. Marker 1, the second marker we selected, is cyan color. All the areas which that marker can see are displayed cyan, and the yellow areas represent those in which marker 0 and marker 1 can both see from their current location. Cumulative coloration works well when you have a large number of observers or markers. We'll select all of our markers and click Apply to run the analysis. Cumulative coloration uses a blue to red color ramp. Blue areas are those that represent only one marker can see, whereas the red areas are those areas that all of the markers can see. It's also useful to display the actual line of sight vectors. So let's turn off the coloration. I can simply hold down the L key and the line of sight vectors appear. A green line indicates that the marker can see that particular location without obstruction. A red line indicates an obstruction. To view a new location, I simply move my mouse, press the L key to turn off the line of sight vectors, and then press the L key to activate it again. If you're planning on exporting your line of sight analysis or merging it with existing analyses, please read up on the help for the image generation options. Directional line of sight analysis is a way to simulate the placement of either a camera or a directional antenna. As with all line of sight analyses, this begins with the placement of a marker. In this case, we put it on top of a building, simulating the location of a camera. Under Markers, I now go into the Edit Marker dialog. I click on the checkbox under Sensor for Sensor Attached, and click the Edit Sensor button. This launches the defined sensor properties. For this particular sensor, I'll point it west and have it point down at -30 degrees. Now that we've set the sensor properties, we can click on the line of sight map, choose our observer, and run the line of sight analysis. We now have a clear picture of the areas covered by this particular sensor. Computing the line of sight for a travel route involves 3 steps. First, placing markers, which I've done here. Second, digitizing a mensuration line, and then finally computing the line of sight. To create the mensuration line, click on the Place Mensuration Line button. Left-click to create the first vertex. Left-click to create additional vertices. And then finally right-click to end the line. This launches the mensuration data window. Click on the Examine LOS vectors. This launches the travel route LOS. As I move the slider bar, you can see on the left-hand side the observers that can see the target at that particular location are colored green. Those that cannot see it are colored red. When I move the slider bar, you can see the line of sight vectors are dynamically updated. Once again, the red lines indicate that the marker or observer can see the target at that particular location. The red lines indicate that that marker or observer cannot view the target. Point-to-point line of sight analysis requires the presence of at least 2 markers. From the Analysis menu, choose Visibility Analysis, Point-to-Point LOS. The Point-to-Point LOS window will appear. In the upper left, you first have to select the From and To markers. Over on the right, information such as the air distance, the delta Z, the ground distance, and the inclination between those 2 points is displayed. You can click on the Show LOS button to display the line of sight vectors. As with the travel route, you can adjust the slider bar. This will move the green dot along the line of sight vector. In addition to changing the From and To markers, you can also retrieve the scatter points to better analyze the obstructions. Finally, if you want to save the line of sight analysis, go to the Analysis menu, go to Save Mensuration, and choose either the KML or the shapefile format. We hope you enjoyed this video. Please check the Applied Imagery website for additional modules and check back regularly as new videos are added periodically.